Good evening, everybody, and welcome to yet another edition of the US vBrownBag. I am very excited this evening because I've been doing a couple of things with some containers, and tonight we've got Cody De Arkland of VMware talking about VMware. Is it VMware or vSphere? It's vSphere, isn't it?
vSphere Integrated Containers.
vSphere, thank you. Duh. vSphere Integrated Containers. We're going to do an install and config tonight, and this man is crazy. We are going to be doing a live demo. This is not pre-recorded. This is all in the wild. So we have sacrificed to all of the demo gods, and we're going to be crossing our fingers. Couple of show notes before we get started. Getting on the conversation, I am monitoring the Twitters. If you hashtag vBrownBag, I will see your questions there. At vBrownBag also, of course. Again, our presenter this evening is Cody De Arkland. He can be found at Cody De Arkland. I'm Chris. I can be found at Mistwire. Feel free to irritate me as much as you want. Take it easy on Cody. He's an awesome guy. And with that, Cody, let me make you presenter. Shablam.
Oh man. Let's get our correct monitor showing.
You have the power. I can see your presentation.
All right, everyone. So as you can see, we have a whopping 4 slides. And that's because I don't want to make this a death by PowerPoint presentation. I like it to be fun and dig into kind of some commands and actually show the setup and really have a good conversation about kind of the benefits of vSphere Integrated Containers, and even talk a lot about just the benefits of leveraging containers anyways. Obviously, this presentation is more focused on the vSphere Integrated Containers component of it, but no reason why we can't talk about everything. So kind of digging in from the top, what is vSphere Integrated Containers? What are they, and how do they play in kind of a regular environment? vSphere Integrated Containers are VMware's take on implementing a container solution within, go figure, the VMware ecosystem. The big benefit to using vSphere Integrated Containers today is that you can start to tie it in with existing VMware products. So if you're using something like vRops internally or vRops operations, you can actually monitor those containers and performance of those containers from within vRops and tie in other products to it. A good example that we talk about a lot is throwing containers on a user network that's backed by NSX and being able to control the destination point of those containers as well as monitor them inside of vRops Network Insight or Verni. We had a session on that kind of recently too. So it's kind of a cool take on the container concept. There are some things that are different. There are some things that are benefits to vSphere Integrated Containers, and there's also some things that are detractors about vSphere Integrated Containers. We'll talk a little bit about both of those, but I wanted to just kind of jump into where we're going to go with this. This slide is really meant to just show kind of an overall picture of what the basic container ecosystem at VMware looks like. We're going to tonight deploy what's called the vSphere Integrated Containers Appliance, so just the VIC appliance. And within that VIC appliance, we have the VMware Harbor, which is our enterprise Docker registry. And then we have VMware Admirable, which is a container management solution. Below those container appliances, well, not below, but from that container appliance, we pull down the actual binaries that will install our container hosts. So we're going to install just a regular vSphere container host, and what that'll do is actually host our containers. One big difference between vSphere Integrated Containers versus a traditional Docker container is that we're used to, as vAdmins, when our developers want to provision Docker resources, we give them a VM, they install Docker, maybe on CentOS, they do a yum install Docker, start pulling down their content, and we can jump into just a simple example of that right here. We're on just one of my CentOS boxes, and if we do a Docker images, you can see I've got a ton of stuff I'm playing with on here at a given time. If we do a Docker info, you can see some basic stuff about the Docker installation that's running on this system. Now, I'll be the first to say that traditionally the regular Docker that's on a CentOS build or on a RHEL build or any of the standard Linux varieties tend to be a little bit more feature-rich in the sense that they're kind of bleeding edge. They have all of the capabilities right out of the gate. Because of the nature of vSphere Integrated Containers, some of that development lags behind. And a lot of that centers around the fact that while we do consider deployments of Docker containers that run inside of vSphere Integrated Containers to be containers. They're really actually virtual machines that are running the bare minimum to run that container underneath it. So they still are actually VMs that are just running the container binaries below it. It's a very kind of fine-lined distinction between the two, but it is something to kind of point out as the difference between. So let's jump into actually doing some fun demo now. We're going to move forward with.
Quick question.
Yep.
In terms of requirements for the system, the minimum to run an E6i host, 6 or 6.5?
Yeah, it will run on 6. It's supported on 6.5. So 6.5 is where it's supportable on. Last I checked, it will run on 6 still. I believe that's being depreciated as the versions move forward. But 6.5 is the kind of the current platform. Also, enterprise licensing is important. vCenter is not required, so you can do this with just a standalone host if you want to. And I'll actually be doing a blog post for the CNA blog around doing just that. And basically, a developer pulls down ESX as a trial edition that has the enterprise features enabled and is able to jump on and deploy vSphere Integrated Containers to check it out. So I'll be doing a blog post around that for the CNA blog, but enterprise licensing is, at least the feature sets are required.
Gotcha. Cool. Thank you very much.
And then when we deploy it against a vCenter host, you do need to have the VDS enabled, so you ought to be using the virtual distributed switching, and that's mostly for the bridge network, and that's really so that the container host can communicate amongst its containers as the host vMotions between. And that's one of the bigger benefits of vSphere Integrated Containers versus a traditional Docker container. When you look at a traditional Docker host deployment, that Docker host is going to live on the virtual machine or the virtual machine host that it lands on. So if you have, for example, let's back out of my quick demo. Let's take a look here. In my environment, where I have 2 hosts in this demo environment, that Docker host that's deployed is always going to live on one of those hosts, and all of those containers are going to live within that virtual machine, right? So there's not a way to intelligently split those containers among multiple existing Docker hosts, unless you're doing something like a Docker swarm and doing some interesting load balancing with that or some interesting load distribution with that. But DRS will generally move that virtual machine between your hosts based on resource contention, but if you're running 100 containers on one Docker host, you could be swinging your resources pretty drastically between each one of those. One of the benefits of vSphere Integrated Containers is that things like DRS function with those containers. So you could have the actual vSphere container host living on my 0.1 instance, but DRS says, hey, it's better for that container to run on 0.2, and it'll move just that container over. Maybe there's 5 containers running on 0.1 and 3 running on 0.2 because that's just how the resourcing balances out. So the benefits of kind of summarizing that, the benefits to vSphere Integrated Containers are that we get to use the native things that VMware does really well to manage those containers. And I don't mean manage as in the software installed on them, but manage that resource pool. And, we talked a little bit earlier about kind of the future of containers and where we're going. There's going to come a day where people are using ESXi and the platform to host containers in mass on the platform. And instead of getting these monolithic, larger VMs and just loading them up with containers, they're going to be provisioning these containers directly against the host, right? So these hosts are going to become the housing for these resources. And we're going to be about enabling tools to manage those containers now, instead of giving a developer a 32 gig memory box to do all of their Docker work on. We're just going to give them a VCH endpoint and a URL and an ops user, which we'll talk a little bit about as we're doing the install, and they'll access their Docker resources that way.
So in the future, you'll be removing even the VM shim layer that's in between the container and the host?
Yeah, so I'm not on the actual CNA team, so I can't comment on that aspect
okay.
of it.
All right.
I think that's the future as things develop and as we bring that integration tighter. I think that the vision of it will be to blur that line as much as possible, right? I think that makes a lot of sense. And even if it doesn't, right, even if they continue to maintain it as a VM in the traditional definition sense, as long as we're enabling as many of the Docker features as possible, I don't think developers will really care, right? If they have feature parity between a Docker host on a CentOS box and the vSphere integrated containers, the developer's just going to want to be able to develop at their house in their boxers, drinking Mountain Dew at 2 in the morning, and be able to push it into prod when they get into work at 10 in the morning because they slept in, right? And as long as the experience is the same between both, I think that's all they're going to care about.
Gotcha. Okay. There is one other question, but I don't know if this is more appropriate for the administration talk that you're going to be having next week. The question is, how is container scheduling handled? Or do we still need Kubernetes or Mesos? Or does DRS now handle the scheduling? And if that's something that you want to talk about next week, that's totally cool too.
We'll dive into it in more detail next week. Generally, container scheduling is an interesting concept because it does, in some ways, parallel DRS. Now, I don't want to say exactly because I think a lot of people who know containers way more than me will kind of point out the intricate differences. But generally, they're in the same concept family of resource balancing and where, similar to how we handle scheduling within the ESXi kernel, right, and how we balance that stuff out. There are people, Ben Corey, who's a fantastic VIC resource. He has a video of doing Docker in Docker and then having the Docker data center management on top of it, which is doing the scheduling. I've seen people do Docker in Docker with Kubernetes on top of it. People are doing Photon OS, which is not the concept of, or not the topic of this conversation, but talking about cloud native, people are doing Photon OS, which does Kubernetes by default. There's going to be a lot of interesting announcements about Kubernetes and the VMware platform as time moves forward. Some interesting developments I can't really touch on too much, but I would say that conversation is going to become more relevant as time moves forward.
Gotcha. Okay. So tune in next week for our episode on administration.
Let's jump into a little bit of the demo now that I've rambled my mouth off for a little while. So typically we go in and we download the actual VIC binaries, or at least the VIC appliance. I've already downloaded it just to save us time, but just for grins, we will bring up the actual URL. And typically you go in here and you just pop in and download it. It doesn't require a license to download. You can download it with any account. Any account that's not entitled to anything even can download VIC. So URL's up here for anyone who wants to grab that or see that or anything special. So we have it right here. We're going to go ahead and do the deployment. Now, interesting side note, I had done a blog post on deploying vSphere integrated containers that was really a fun blog post to do. And in this post, which I have up on the screen now, we had gone through and done all of this via Power CLI. Well, unfortunately, Power CLI has some struggles with handling SHA-256 for OVF deployment, specifically this guy right here, and really the get OVF properties commandlet, which is somewhere else in this document. Oh, right here, right below it. So unfortunately, when I went to do that this morning to test out the new version of VIC that was GA'd, so 1.1.1, it told me no, and there's not a workaround for that right now. So we're going to go back to deploying an OVF as normal through the UI, but soon this will be fixed and you'll be able to move back to actually doing this via Power CLI, which is a much slicker way to do it because we all know that the web interface has its struggles, and I have no delusions of grandeur. So it's important that we're deploying the VIC appliance here, and remember I said before the VIC appliance has the Harbor Docker registry as well as the Admiral management interface, and on top of that it also has the downloads for the VIC container host binaries and the UI customization, things like that. We'll drop this on our existing tenant. I'm going to go out and validate that it's a signed package, which takes a little bit of time. Looking good. Go ahead and accept. We're going to drop this just on my standard small storage that I have on here. And next week, we're going to talk a little bit about the benefits of dropping container hosts on NSX virtual wires, just from a monitoring and management perspective. We're not going to do that this week. We're going to keep it on just standard networking this week. We'll drop it on my LAN network, which is just my standard 192.168.1.0 network. We'll use the ever popular default VMware password for all the things.
Is it one VIC host per ESX host, or can you add multiple ones?
You can have multiple ones, and that's a great question because that ties into multi-tenancy, right? So if you have a developer, say one of your developers their team is focused on Node.js development, and then you have another group that's focused on database development, you probably wouldn't want to give them the exact same VCH host, right? You might want to give them individual ones so that they can manage their resources, or they might have paid you for more resources, so you have higher limits on one of those containers versus the other. So really, I could see scenarios where there's 15, 20 container hosts on an individual ESXi host. Really, it's important to note that I don't like, personally, this is Cody's opinion, not VMware's opinion overall, but I don't necessarily like that we call it a vSphere container host, because that makes it sound like it's almost a virtual machine, or a virtual machine host in itself, right? And that we're doing nested virtualization in some weird way. But in reality, what that VCH is an endpoint. It's an API endpoint for Docker. So think of it as a translator to how to talk to the Docker resources within VMware. So that's why you can have these containers live on a different host in the environment versus their container host living on a different host, right? The example over here of the container host living on 0.1, but the containers living on 0.2, because really the API endpoint knows how to talk to both ESXi hosts, right? So we're going to drop this on .60 address, and that's because I already deployed some DNS records for that. Standard gateways. My Humble Lab domain. Oops. That was almost a mistake. Almost a live demo fail. So now as we drill into the actual setup, you can see we're getting into registry configuration. So this is for the Harbor component. These are all just general passwords for the platform. In the interest of preparing well, I went ahead and pulled down the certificates already.
Nice.
So we have those to make everything secure and pretty. We're going to do the key in just a second. We have individual certs for each component, so if you use like Nginx to load balance it and you wanted to put a different subdomain in front, like harbor.blah.com or vic.blah.com, you could do that too. But since we're using the same cert for all of it, we're going to drop that in there. And then we're going to grab the key off of actually here. Oh, you know what? I actually copied the key elsewhere. All right. I'm just tabbed over, grabbing the key off of a different host right now.
When you have a second, I have an additional question.
Shoot, go for it. I'm just pulling it down right now, so go ahead.
Do the Docker containers behave like regular VMs, or do they behave differently, i.e. snapshots, the ability to back up, vMotion, all of the regular things that we can do with a regular VM?
Most of them will work, so you can do backups and restores. I've heard about people doing that. I haven't actually done the backup and restore component. Most general VMware features will work on a actual container, so within the vSphere container host. vMotion, mentioned that already between the two.
Mm-hmm.
Storage vMotion, I've heard doesn't work. I haven't tried storage vMotion, but I've heard that there's been some wonky issues with storage vMotion. But people have been consuming vSAN with vSphere Integrated Containers. Trying to think of what other major, standard API calls will work to them as containers, or not as containers, as virtual machines. So if you're working with the REST endpoints, so on and so forth.
Did you already speak to snapshots?
Snapshots, in theory, would work, but you would probably have some interesting problems with them, because typically, if you think about how you should be leveraging a container, you really shouldn't be snapshotting it anyways, right? Containers are generally designed to be ephemeral in the sense that if something goes wrong, you blow it away, and you really shouldn't be going into a container and making changes to it. You typically have a persistent backend, or they'd be communicating like a database on the back end that you would be snapshotting as a real virtual machine or something like that. In theory, snapshots would work, but I would question the why.
Gotcha. Because your persistent data isn't going to be anywhere near this.
Yeah, nor should it be if you're kind of paying attention to those kind of I want to call it the Docker concepts.
Gotcha.
Oh, what did I do wrong? One property has the wrong value. Typing is hard. Words don't own us, at least not anymore. All right, so we got all our stuff set up, so on and so forth. We're going to go ahead and just do finish. Now if we drop down into our task screen, we will watch it fire off and start.
Cool. While that's firing off, Charles has an additional follow-up question. Could the
Charles?
Charles Adams?
I said hello, Charles.
Hey, Charles. Could they be added to a vApp so that the containers and the persistent backend data could act as a single unit?
It's interesting because when you'll see as we deploy this, they are by default added to a vApp within a host, or underneath that vSphere container host. So I'd be interested to see the long-term impacts of that. I haven't looked at the impacts of running it as a vApp. It's a really good question. I will take that back internally and see if I can find some examples or some of the benefits from an engineering perspective on why to use it as a vApp, and if there's benefits to that, or breaking them out of a vApp, what does that mean? I think that they're tied to a vApp right now, just in the sense of if you power off your vSphere container host, the container should go down as well too, it being the API endpoint and all. That's a good question. I will dig on that and I will get back. I'll hopefully bring that back next week with the management conversation. I can answer that.
Awesome. Yeah, look, that's open season to get you loaded up on follow-up questions now. Be careful.
Right. I appreciate follow-up questions.
Totally.
So, while this is deploying, so we pop back into vCenter, we see it's moving along. Talking a little bit about the why of containerization and the benefits of using containers. I don't know how many of you follow me on Twitter. I have a whopping like 140 followers, so I'm pretty serious.
142 now.
That being said, right, 142. I've been working a lot with William Lamb and a few others on deploying a set of basically a web page that functions as a proxy for talking between an Alexa, like an Amazon Echo device via Alexa, and VMware APIs. And we were developing this solely on desktops independently. You know, we would commit the code up into GitHub and pull it down and work on bits and merge and all the stuff. And after a while, it got to the point where we thought we need to make our installation and our configuration as similar as possible so that when we start distributing this out to other individuals, they're getting a consistent experience. Moving it into a Docker container actually moved our ability to develop faster against the platform ahead light years, and it turns it actually ends up being a much simpler development process. You get into this process of pulling up the code, editing the code, pushing it to GitHub, cloning it back down, and running a Docker build. And talking about containers while that's building, we have a few minutes here. I'm going to do an unscheduled demo. It's completely off the rails, so this could completely backfire. We're going to go completely off the rails now.
Oh, and while you're going off the rails, I'm sorry, go ahead.
I would say that Pi VMware Alexa is the actual app we're talking about, so I'm going to nuke that directory, and we're going to clone it back down again. But go ahead with your question, I'm assuming.
Yeah, Matt is asking, how is VIC licensed, socket or by container count?
VIC is not licensed. VIC requires enterprise licensing for your ESXi hosts, but VIC itself does not require it. You're not buying VIC. You can't go to your rep and say, hey, I want to buy 54 sockets. You can't do an odd number sockets, or I guess you could, either way. You're not buying socket licenses for VIC. You're buying it for the enterprise licenses for your host, so typically per socket or whatever you worked out with your with your rep. But VIC itself is not licensed.
Nice.
So we're going to pull down from our registry. Make sure I spelled it all right. Cool. I have to make a quick change that we were doing from a development perspective. So this is actual Docker files. So Docker files are how you build Docker containers. You can see that basically what a Docker file does is just the manual steps that someone would take to build out an environment, right? So we're going through, we're installing a bunch of stuff via Yum. We're installing Python. We're dropping into a virtual environment. This is all going to be covered in a future vBrownBag in August, so I'm not going to go too deep into it. I just needed to delete that out. That's a developer thing. Now if we do a Docker build T, and we'll name it. I'm using V1 for a bunch of stuff, so we'll do V2. As much as I want to demo this and actually demo the Alexa integration, I have to save that for the future the future vBrownBag. But we'll show it start up anyways, just so you guys can see what we're talking about. And there we go. So you can see how if we would make just simple quick changes to the build, and if we wanted to change something, we're going to power this on real quick, and I'll show you what I mean with that as this powers up and grabs this IP address. So it's going to power up, it's going to grab its IP and everything that I statically set, so that's going to take a few moments. Say we want to change this title right here to something else in our quick development fashion, right? Because we're crazy developers and we like to change stuff on the fly.
We are? Oh, okay.
I like to think I am sometimes. Completely off the rails. I feel like this is going to backfire on me very badly.
By saying it is, you're almost guaranteeing that it won't. I think that's kind of the
That's why I did it. Believe it or not, that's exactly why I said that. So you see, we made a quick change. Right? We went in and modified some of the code within the locally committed file or locally cloned file. Made some changes, rebuilt the container. It took us about, I think, 12 seconds to rebuild that container. We retagged it to version 3 instead. You see right here. So now if we do a Docker run as version 3, it's going to fire back up. We're going to pop back over. Please don't work. Please. There we go.
Oh, it is good for you. Thanks.
Right. So you can see how rapid development is much easier with a Docker container, and it might be easier for you to just rerun the development interface and run the website locally, but making those changes against the Docker container ensures that anybody that pulls that container down is going to have the exact same result, right? Every time they build it. If I committed this back up now, every time William pulled down that container and did some development work on his side, he would have the exact same experience that I had. So it's cool, it's fun, just like vBrownBag, it's good for you. All right, back to the regularly scheduled programming. Our host is up, or at least we hope it's up. Now, Chrome's going to probably scream at us because Chrome recently did a change that doesn't like certs that don't have a subject alternative name to them, and I don't have a subject alternative name to my cert. So it's probably going to bonk at us and say, thou shalt not. Oh, I had already accepted it, so just because we like to be OCD and not have red alerts, let's open this in IE. Cool. So we're happy. My super secure Humble Lab domain controller's certificate authority is in charge. This is the Harbor registry. So if we can log in here with our username and password. And we see all of our stuff. This is going to be detailed a lot more in the administration management conversation next week, so we're not going to do much in here. We're going to close out our previous container. So now we have our VIC appliance. We've shown that it's up and running. We've seen that Harbor's there. We're not going to touch on the management side, so I'm not even going to click on it. Typically now what we would do is we would go in and we'd pull down the actual tars for the VIC and untar them and all of that stuff. I already did that to save us on some time, and does essentially extract out to this folder right here, so we don't need to do that either. So see in here we have a number of platform VIC utilities. Since we're working off of a Linux box right now, we're going to use the VIC machine Linux. And if we pop in there and do a VIC machine Linux, you can see a help. The VIC team did a great job at documenting this stuff from a command line perspective. So if we do a -H, we can see basic. And if we do a -X, we can see a whole lot of stuff. Let's turn our font down a little bit so we can see just a little bit more per screen. If it's too small, people yell at Chris so I can make it bigger again.
We're recording.
I'm going to assume that
it'll be fine.
I'm going to assume this is good enough.
Yeah, we can see it.
There's a ton of options here. I'm going to use some specific ones, and we can talk briefly about what each one of these tie into. Target is ultimately a vCenter endpoint or an ESXi endpoint. Go figure. ESXi or vCenter connection URL. User is the user account. Password is password. We're going to come back to thumbprint because it's an important concept that you will almost always fail on the first time. Name ties into the actual host name of the container host itself. Compute resource is a cluster. Opt user and password would be used if you wanted to set up, say that I was hosting, and Chris, I wanted to give you a container host to do your development on, and I wanted you segmented off from the other vBrownBaggers because they aren't to be trusted. I would give you an ops user and an ops password to do your work in. So you would connect your container host with your ops user and password, and you would be the only one that has access to it. Image store ties into a data store path where the images will be stored. So when you do a Docker pull and it pulls down the image, it ties into where that would be stored. Base image size is just the size of how much space the base images take up at a given time. Container store is where it's not supported yet, but eventually it'll be a separate store for containers that are built. Volume store is for persistent volumes. So if you're going to do Docker persistent volumes, a good example of that is like an Nginx reverse proxy. So if you wanted to have a reverse proxy and a load balancer set up on Nginx as a container, but you wanted it ephemeral so that you could destroy the container and rebuild it and still keep the same configurations, you would drop your configurations into that persistent store. That way when you destroyed the container and built a new one, you would map that persistent store back in and you would keep your data. So that's one of the tricks you can use to make Docker containers still ephemeral, but retain the important stuff. So you would map just a specific directory. So like in Nginx, it would be /etc/nginx/confd/whatever conf file for your website configurations. This stuff right here is the important stuff. So a bridge network is how the container hosts talk to each other as well as how containers talk to one another. This tripped me up for a long time because I use, by default, the VIC appliance uses 172.16.0/12 or 0.0/12. I have a management network inside of that range. So when I would deploy containers, it would fail, and I spent days trying to figure that out, only to find that because I had a gateway and a network that overlapped, it would not work. So if you don't have anything that's on 172.16, you'll be fine. If you do, you will not. So in my example, we're going to use this configuration to change the bridge network. Client networks relate to how the VCH talks to end user clients. Public network is how containers talk to the rest of your network, so where they land, what their main IP address is, if you're not using a container network. So if you're using a container network, you're giving each container its own dedicated IP address. Maybe you're having like an overlay network that you're using with like NSX. So you're deploying it onto an NSX network. This is the container network down here. If you're using that and deploying it onto NSX, it's not going to land on a public network. There's a little distinction there. Management networks are for management traffic. If you want to get crazy and segment stuff, DHCP server or DNS server, I think makes sense. I'm going to explain that. These all tie into restrictions, so restricting memory or restricting CPU. Words are hard. TLSC name ties into the self-signed cert that's generated. If you're using self-signed certs, this all ties into certs. No TLS verify we are going to use just to disable it to make things simple. Again, certs, all the things. Reg.ca value is for Harbor or any other Docker registry you want to use. So if you want to push the certificate in so that you don't have any weird problems down the road, that's a good idea. I already have the certificate on the system, so we're going to push that in anyway. Insecure registries if you didn't want to use a cert with a registry. Proxies for communications externally out to the internet. So there, at my former employer, there are about five container hosts that still exist that have a proxy set up that they would probably be very disappointed in, but I don't work there anymore. So these are for if we wanted to force a different appliance ISO or bootstrap ISO, resource pools, so on and so forth. The help's really good. Read the help. Fortunately, we're not to type all of that out. I already did this command and saved it. You're going to see my clear text default VMware password that I changed specifically for this.
I was going to say. Oh,
classic.
come on.
Classic, huh? All right.
You added a 23 in there. That's totally out of the norm.
Do a good job. Oh, what did I tell you? Everyone's going to fail on this the first time, because most people don't have the thumbprint for their instance memorized, almost always you will fail this the first time. You will then copy your certificate thumbprint. You will append it to your command, which I'm doing on a different screen right now. And we will try again. Alternatively, we could just do up because those backslashes, just chaining it all together. So you could just do // or just do up, then do -- thumbprint, and then the value. What did I do wrong?
Thumbprint and then something.
Oh, there it is. I didn't do the equals. That's one demo fail. That's one demo fail so far. Man,
You are
almost a flawless victory.
You are
almost
tempting
a flawless
fate, sir.
victory. I'm just gonna hang up. We're done with this conversation. It isn't fun anymore. A lot of good stuff happening in here. You can see it. It's pulling down. It's actually using the registry cert that I specified. It's grabbing the IP. It's doing an API check or an API check against it once it comes up. So if we pop into vCenter. Oh, look at that little fella. That's a V app. How quaint.
So quick question for that piece of it, actually. Does standard vCenter work down to the container level, i.e. in vCenter, say you can say who has admin rights, read rights, etc. to parts of the tree. Does that extend down to the containers, or is the container host the endpoint for vCenter security?
Because they are still vCenter objects within the platform, they would be a part of that. So if you had persistent containers that were running forevers and evers, you could assign permissions to those, right? So if you had stuff that you kept in there, like a Nginx reverse proxy or a WordPress blog, as a funny example, you could assign permissions to those and say only Chris can see that container specifically.
Gotcha.
Yeah, they are managed objects within the platform. Now we have our endpoint. We're cruising up on the end of this demo, just as a heads up. So now with this, we can do interesting things like images. We have no images. We can pull down images from the standard Docker repo. We can do run IT. So IT means IT lets how we get into the container, so it runs it as an actual target that we're logged into. You see that container spinning up right there. And now we're in. You can see it running standard logs, right? So we can see it has its IP address as 192.100.0.2. It's got a default gateway, so on and so forth. So we're actually, effectively it's a VM, right? We're looking at the console view. Pop in and do ls. This is a real container, right? If we go in and we exit the container and we do a docker run IC, or not even that, we do docker run detached 8080 Nginx. Another. I was not planning on doing this demo either. Was not planning on this one. We're going 3 for 3 on unplanned demos. I too like to live dangerously. If somebody posts that meme to Twitter, you have to tell me.
Extra points if you get the movie as well.
If you get the movie as well, it's extra points. I may be able to be persuaded that the first person who posts the meme with the movie, since Chris obviously knows it, may end up with the shirt in the mail.
Graham,
I may pull that off.
Graham got it. Graham Mitchell.
All right, you'll have to sync me up with Graham, and
yep.
I will get Graham a shirt. So this container is now running within that remote endpoint. So the 6.1 endpoint, we mapped it to .61 endpoint. Sorry, to be specific there. We mapped it to port 80 on that host. So in theory, if we pop in here now and we go to HTTP 192.168.1.61, is it going to work? Is it going to work? Maybe, maybe, maybe. It's unhappy for some reason. It's probably still coming up. It takes a little while to boot those up, so that demo may have failed. Oh. All right, while that's doing its stuff. Now, to answer the earlier question, what do we do about if we want to have multiple containers per host, or can we do multiple containers per host? This will be the last demo we do before we just open up for real questions. You can go in and create number 2. We will go and change this to 200. We will up its IP address by 1. Perfect. Waiting for IP. So we just built one on the fly. There's another one. Then again, we can do run ITD, or not IT, sorry. We'll do / attached, so we're not in the target mode. We'll do /port 80, Nginx. Now we have this new one over here that we spun up. It's currently pulling down that Nginx container again. It's extracting it, it's doing all kinds of magical ninja things. That container is now starting up. No VMware tools. But why?
What?
Ooh. Something went wrong with that build. So that qualifies as a demo fail as well.
You were going too strong.
It's all right. It's all right. No one's perfect. Let's talk a little bit about, just kind of summarize since we're coming up on the hour here. We talked about the installation of the VIC appliance, and that gives us our container registry, our container management, as well as the binaries that we pull down to do the actual VIC installation. We've done the actual VIC appliance install, doing the deployment of we did the appliance install via OVF that gave us the container management as well as the Docker registry. We then did the actual VIC machine deployment, so the virtual container host deployment. We showed the ability to connect from a remote host into that and perform API calls like info or Docker pull or Docker run, so on and so forth. We've shown kind of the benefits of using containerization and the speed at which you can develop, push changes, make changes, clone things down from a repo, and kind of the developer friendliness of them. We talked about the different VIC options from what the different command line switches do, looking at VIC machine create, Linux create. Talked about the different options and benefits there. Something to leave you guys with. I did my blog around deploying vSphere container host. Pretty good guide running through. I'll be doing another one for the CNA blog soon to go through kind of the setup, what you get out of it, how it can be done in a very quick, developer-friendly way.
Cool.
And then we also did a demo of using my own container. So.
There's actually one follow-up Alexa question. Does that mean I can tell my Alexa to vMotion some guests?
So the struggle with that, and that's going to be a long topic of conversation at the vBrownBag I do in August. But okay. We're trying, and it's easy to do when you have very distinct names. So if you had, say you named each one of your VMs a very distinct name, natural language processing could handle that. And you could say, Alexa, move blue. Alexa, move red. Alexa, vMotion red to host 1. Well, even host 1 will fail because Alexa will interpret that as host space 1, right? So there's a lot of code that has to be done to handle that.
Okay. So the natural language of Alexa would be tough for the way that we think of it. We'd have to like have Tweety and Sylvester and
exactly
stuff like that.
Now there's ways around that, right? It's all written in Python. So you can get crafty with like regex, and you can nuke spaces. So you could have the Alexa input be a certain way, and then have the Python code kind of shape that response. So when you said ESXi1 and Alexa did the space, you could have a regex there that would nuke that space, right? And you could get pretty creative with it, but it would significantly increase the code. So a lot of stuff we're doing right now is read operation. So I just William Lamb pushed some of the vSAN stuff to get vSAN data. So get vSAN version, get VAMI version. I did get uptime. We had about 12 other ones that already exist. So if you go read my blog, thehumblelab.com, or take a look at William Lamb over at Virtually Ghetto, we both have a pretty hefty amount of information on there about it. Also, ping me on Twitter about it. I think we've combined had somewhere in the neighborhood of 30 commits over the past 3 days. So we're doing a lot of work around it right now. Yeah. Cool.
So we actually basically did all of the questions as we were going through the content. So as of right now, I don't have anything left. Let me double check. Twitter's clean. Refresh. And nope, we're good. We're good for questions. Are there any things that any kind of questions that you get hit up with on the regular that like common things that people ask you?
A lot of them were answered along the way. The questions about when I say it's treated as a VM, what does that mean?
Gotcha.
That's a common one that's asked. What does that really mean? And kind of what are the benefits of using a Docker container or using a regular Linux host with Docker containers installed versus using a vSphere integrated container? And Ryan Kelly from VM to Cloud years ago told me kind of what ended up being kind of the best kind of description of it for me at the time. vSphere integrated containers are containers for the VMware admin. So they play nice with all of your existing VMware products. If you're an organization that really wants to let developers use containers, but you still want to maintain the investment that you've made, you still want to use the platforms you did, you want to deploy with VRA and be able to deploy containers with VRA, or manage their resources with VROPS, or tie them into Log Insight or Verni or NSX. vSphere Integrated Containers are great for you because they speak the VMware language, right? They're tied and they're developed from the ground up to be functional with our suite of products. If you want to go true cloud native, you want to break free of existing paradigms, you want to do everything 100% cloud native, looking at things like Photon platform is where you want to be, because that's a completely different abstraction of virtual machines and getting away from the legacy concept of what a virtual machine is and getting into real containers and real cloud native. But we're still a long ways off from that as an IT field. You know, some are further ahead of us than others. Places like Netflix that has Chaos Monkey running around the entire data center, destroying parts of the environment and letting it automatically rebuild. You know, there are a few companies that are at that level of maturity. Many of us are in the boat of, hey, I've spent this money on VMware products. How can I let my developers do development work, but still use my platform to manage it?
Gotcha.
That was a long-winded answer for a pretty simple question that was asked way earlier.
Awesome. Well, thank you very much, Cody. That was fantastic. There's a lot of good feedback on Twitter about the content. There was a lot of good interaction for it, and that was awesome. I'm very excited to host next week's as well on administration, so we can even dive even further, and you can come back with the answer to Graham's question.
Yep.
Cool. All right. Well, thank you everybody for attending the episode, and we'll see you again next week.